Rational functions, adding and subtracting. Okay, I'd like you to pause your video and write down anything that you need to write down from the screen, and then restart it, and I will explain. Okay, first step that we're going to do whenever we're adding or subtracting rational expressions is to factor everything. So we're going to factor all parts possible, and that's going to help us with step 2, where we're going to make common denominators. We might do that by canceling some common factors out, or we might have to multiply the top and the bottom by a common factor in order to make common denominators. Just a quick side note here. Remember, whenever we're adding fractions like, say, 1/2 plus 1/3, you can't just add like parts. You have to make common denominators. So in this case, my common denominator would be 6. I could multiply the top and the bottom of this by a factor of 3. And I could multiply the top and the bottom of this one by a factor of 2. So that would give me 3/6 plus 2/6. In the end, I would add my numerators, so I would get 5/6. Adding and subtracting the numerators is actually step 3. You might have to use FOIL or box method in order to do this, but just combining the tops pretty much. And we keep the bottom the same. So in my example up there, see how I kept the 6 the same. And then part 4, we're going to simplify our answer. We might be able to factor something out, just like in concept 39, and cancel something out of the top and bottom. We won't know until we get to that point. Okay, this first one, we're adding two rational expressions together, and then we're going to remember to state the restrictions just like we did in the last concept. Okay, so my first step is to factor. There's nothing to factor really. I could factor this. I could pull a 3 out, but my goal of factoring would be to get common denominators, which I actually already have. So we'll just go ahead and say we've got step 2 done. So step 3, we're going to add or subtract the numerators. In this case, we're adding because there's a plus sign. So I'm just combining like terms up here. My 1v and 6v will give me 7v, and -1 and -3 will give me a -4. On the bottom, I keep the numerator the same. And then step 4 is simplify. So I'm looking to see if I can factor this. I can't. I can't pull anything out of 7 and 4, so this is just my final answer. For my restricted values, again, I'm looking at all of my denominators. They're all the same. So I say, what would make this 0? Well, 8 times 0 would make my denominator 0. So my restricted value is v can't be 0. All right, next one. I do need to make common denominators, so I'm going to start by factoring everything. This might help me make common denominators. So 3x plus 15, I can pull a 3 out. And on the bottom, x squared plus 5x, I know I can pull out an x. And then we have plus, and we can't factor 6 or x, so I'm just going to leave them the same. Okay, so to make common denominators, I see that in this first denominator I have an x and an x plus 5. In the other one I just have an x. I'm actually going to get lucky in this problem because I can cancel out an x plus 5 off the top and the bottom. And then if I rewrite this, I'm going to have common denominators. It won't always work that way, but it did in this problem. So now that I have common denominators, I just add the tops. 6 and 3 makes 9. Keep it over x. My restricted values, I'm going to look back at all of my denominators. And I see that, first of all, I have just an x. So the only thing that would make that 0 is if x were 0. And then x plus 5, that would be 0 if x was a -5. So those are my two restricted values. Okay, next one, same thing. Common denominators, I don't have common denominators, so I'm going to see if I can factor anything to make it easier. I can't factor anything on this, so I'm just going to have to create common denominators. If you recall from the example I did at the very beginning, the 1/2 plus the 1/3, I made common denominators by multiplying something on the top and the bottom. So in this case, one of my denominators has just an x, and one of them has an x minus 1. So that's what I'm going to multiply each of those by. So I'm going to multiply this fraction top and bottom by x minus 1 so that I have a factor of x minus 1 in the bottom, and this fraction top and bottom just by x. So what that looks like now is on the top I will have 6 times x minus 1, and on the bottom x times x minus 1, plus 5x times x is just going to be 5x squared. And on the bottom down here I have x times x minus 1. So now you see I have common denominators. Some of you might be thinking, oh, we can cancel out these two terms right here. I don't want to do that because then I would end up back where I was a second ago without common denominators. So now that my denominators are the same, I'm going to add or subtract the numerators. In this case, we're adding them. Before I can do that, though, I'm going to need to distribute the 6 to simplify the top here. So I have 6x minus 1 plus 5x squared on the, I'm sorry, not minus 1, 6x minus 6 plus 5x squared. That's going to be on the top. And on the bottom, I have my common denominator, which is x minus 1. I could rewrite the top of this in standard form where I put 5x squared first, just to make it look nicer, but you don't have to. Restricted values, if I look back through, I have an x, I have an x minus 1, x minus 1, that looks like all the options that I have in here. So x can't be 0 or positive 1. Okay, this next one we already have common denominators, so I'm not going to worry about factoring right now, and I've got common denominators. So I'm just going to add or subtract the numerators. In this case, I'm subtracting, so it's going to be 2v minus 3, and then it's a minus 1. If I had multiple other terms going on here, I would need to distribute this negative to everything over here, but there's just a 1, so I'm just going to distribute it to the 1 over my common denominator, which is v squared minus 4. That ends up being 2v minus 4. The negative 3 and negative 1 makes negative 4 over v squared minus 4. Okay, and now this simplifying step comes in here because I can actually factor the top and bottom, and maybe something will cancel out. On the top, I can pull out a greatest common factor of 2. On the bottom, this is a difference of squares. We talked about that in the last concept. Difference means subtract. There's a subtraction sign. And squares, perfect squares, this 4, we can take the square root of it. If we take the square root of 4, we get 2. So it's going to be v plus 2, v minus 2. Notice I have a common factor on the top and the bottom that I can just go ahead and cancel out. And my final answer here is 2 over v plus 2. Again, recall from the last concept, I cannot cancel out these two 2's because the bottom one is attached to the v with addition. Looking at my denominator, I probably want to look at my factored denominators. And that would show me that my restricted values are 2 and negative 2, because that would make those factors 0. Okay, next problem, we're going to factor everything to see if we can make common denominators easily or not. So the first fraction, x minus 1 over x minus 2, there's nothing to factor there. Minus. Now if I look at the top trinomial, I'm trying to say what multiplies to negative 2 and adds to positive 4. I think I said that wrong. Multiplies to negative 4 and adds to positive 4. If you take a minute and think about it, the only factors that multiply to 4 are 1 and 4 and 2 and 2. No combination of these will multiply to a negative 4 and add to a positive 4. So I can't factor this, and that's okay. Now we look at the bottom one. We want to say what multiplies to negative 12 and adds to positive 4. If you need to write out your factors of 12, that's fine. We see that 2 and 6 are going to work. If I have a positive 6 and a negative 2. Again, that's because 6 and negative 2 multiply to negative 12. and add to 4. Okay, so now we're ready to look at our denominators. I'm just focused on the denominators here. I see that both of them have an x minus 2. That's good. I also see that the one on the right has an x plus 6. So that's what I need to include over here on the left. So I'm going to multiply the top and the bottom of this fraction by x plus 6 so that now my denominators are the same. Okay, let's write this out. So on the top of the first one we have x minus 1, x plus 6. And on the bottom we have x minus 2, x plus 6. Okay, common denominators have been made. Now I'm going to add or subtract the numerators. Well, I can't really do that until I put this in a different form. So here's where FOIL or box method comes into play. You either need to FOIL these two to multiply them, or you could do box method. I suggest you find somewhere out to the side of your paper and do that. I'm going to do box method over here. Okay, after I do that, I see that the top, the numerator of this fraction, is going to be x squared plus 5x. I'm getting that 5x from combining these two like terms. And then minus 6. My other numerator, I'm going to need to distribute this negative to. So I'm going to change all of those signs. Minus x squared, minus 4x, and plus 4. I can write this all over my common denominator. And now I'm ready to simplify the top. So it looks like my x squareds are actually going to cancel out because they add to 0. And then 5x minus 4x is just x. And negative 6 plus 4 is going to be a minus 2. Still over my common denominator. Okay, now that I've simplified that, added the numerators, I can do my simplifying step. I see that I have a factor of x minus 2 on the top and the bottom, so those can cancel out. And my final answer is 1 over x plus 6. Looking back at all of my denominators, all I have in there are x minus 2's and x plus 6's. So my restricted values are going to be positive 2 and negative 6. Okay, I would like you to pause your video, try the independent practice problems, and then restart it to see my answers. Okay, this problem had quite a bit going on. My common denominator was x plus 2, x minus 2. I needed to do some distribution right here, and then I had to use box method up here for this pink part. This pink equation came from the box. Whenever I combined my like terms in the middle there, I got minus 7x. I had to distribute my negative and then combine like terms. Okay, for this problem, my common denominator was x and x plus 7, so I multiplied each fraction by what I needed to. I had to distribute my 4 up there, combine like terms, and then in the end, make sure that you factor the numerator to be 7 times x plus 4, because maybe something would have canceled out. You always want to make sure you leave it factored like that.